Hello. Welcome to this video. Here we will see what a PLC is, how it works, its main components, and who are the most recognized manufacturers in the industrial automation sector. PLC stands for Programmable Logic Controller. It is an electronic device designed to be programmed and to control specific processes, machines, or even complete production lines in different industry sectors. It can also be considered an industrial computer, as it has special features that allow it to operate continuously and reliably, even in demanding environments or adverse conditions typical of the industrial setting. Next, we observe a basic example that illustrates how a PLC can intervene in different automation tasks. In this case, the controller receives a signal from a sensor and, based on the established programming, can activate a motor. It can also monitor the level of a tank and control valves or pumps according to the detected conditions. These actions are possible because the PLC has been previously programmed to execute specific responses to certain input signals. It should be noted that, although this is a simple example, in practice there is a complete electrical design behind it, both at control and power levels. However, the essential point is to understand that this type of solution, and many others more complex, are perfectly feasible through the use of a PLC. The PLC is usually installed inside a panel or electrical cabinet, along with various distribution, protection, control, and signaling devices. Following the previous example, sensors are normally connected through signal terminals, and from there to the PLC input modules. In the case of motors or pumps, the PLC does not energize these loads directly. Instead, it activates outputs that control relays or contactors, which are designed to handle higher levels of current and voltage. It is worth mentioning that this is a broader topic, involving electrical design concepts both in control and power, and is better suited to be addressed separately in a dedicated video. Although models may vary according to the PLC brand or size, almost all share a basic structure composed of the following key modules. First, the CPU, or Central Processing Unit, is the most important part of the PLC. It is commonly known as the brain of the controller, as it is where all control logic is executed, data is stored, and communications are managed. Inside it is the microprocessor responsible for executing the user program, the memory that stores instructions, variables, and states, as well as the operating system that coordinates the overall operation of the PLC. Also, it is in the CPU where the scan cycle takes place, a fundamental process that we will explain later in more detail. The power supply is another fundamental component of the PLC. Its main function is to convert the mains voltage, such as 220 or 120 volts AC, into a 24-volt DC voltage, which is what the PLC needs to operate. In compact models, this power supply is usually integrated into the unit. However, in modular PLCs, it is generally installed as a separate module. It is important to clarify and recommend that this power supply only powers the PLC itself, that is, the CPU, the input and output modules, and the communication modules. It is not designed to supply power to motors, actuators, or other relatively high-power external loads. Although its operation may seem simple, the power supply is essential to ensure the continuous and stable operation of the system. Input modules allow the PLC to receive signals from the environment or the process being controlled. Through these modules, the PLC can detect events such as pressing a button, the presence of an object via a sensor, or a change of state in a switch. The signals it receives can be digital, working under an all-or-nothing scheme like an open or closed contact, or analog, representing variable values such as temperature, level, or pressure. Each signal connects to a specific channel within the module, and each channel is associated with an address that the program can read and process. In compact PLCs, these input modules are usually integrated into the unit, while in modular systems they can be added according to the specific needs of the application. Output modules are responsible for transmitting control signals from the PLC to process devices. Thanks to these modules, the PLC can activate motors, turn on lights, open valves, or send commands to other equipment. Like inputs, outputs can be digital, working in an all-or-nothing mode, or analog, allowing control of variable values such as motor speed or valve position. Each output is assigned to a channel and a specific address within the system and can be configured to operate with different types of electrical signals depending on the type of device controlled. In compact PLCs, output modules are usually integrated into the unit, while in modular systems they are added according to the project's needs. Also, in a typical configuration, communication modules can be found that allow the PLC to connect with other devices, such as HMI screens, other PLCs, SCADA systems, variable frequency drives, and even modern sensors or transmitters. These modules use different industrial protocols such as Ethernet, Profinet, Modbus, DeviceNet, among others, to exchange data and commands efficiently and securely. Thanks to these modules, the PLC can integrate into larger networks, facilitating supervision and centralized control of complex processes. As mentioned earlier, compact PLCs integrate all their main parts into a single body and normally only require mounting on a DIN rail for installation. However, this does not mean they cannot be expanded. In many models, it is possible to add expansion modules, whether input, output, or communication, if the application requires it. This expansion capacity allows adapting the compact PLC to projects with greater needs without completely changing the unit. In some modular PLCs, each module is also mounted directly on a rail, and when adding a new module on the side, it is necessary first to place a bus connector on the back. This connector allows communication between the modules in an orderly and continuous way. On the other hand, there are modular PLCs that require a chassis or rack. This rack incorporates an internal bus line that allows interconnection and data exchange among all modules in a centralized way. It is also the physical structure where the different system components are mounted and connected: the power supply, the CPU, the input and output modules, and the communication modules. To understand how a PLC works, let's start with a simple sequence that allows us to visualize what happens internally in each cycle. We can say that the PLC first reads the inputs, that is, it detects the state of sensors, switches, or other signals from the environment. Then, with that information, it executes the program containing the logic designed by the user. Finally, based on the results of that program, it updates the outputs, activating or deactivating actuators such as contactors, valves, or lights. This sequence, read, process, and act, is repeated continuously, and it is what allows the PLC to make decisions in real time. The user program is developed on a computer using software compatible with the PLC model and then transferred to the unit's memory for cyclic execution. Now, if we take a specific model as an example, such as Siemens PLCs, the internal order of that cycle has a slight variation. According to its official documentation, the cycle begins by updating the physical outputs with the values stored in the internal memory, known as the process image table. Next, the physical inputs are read, and their values are also stored in that same memory. Then, the user program is executed using the values stored in the process image memory. During that same cycle, communications are managed, events are processed, and alarms are handled if configured. This structure ensures that the entire system is synchronized and that the PLC responds reliably to changing process conditions. In the field of industrial automation, there are several well-known PLC manufacturers, each with its own approach and a wide range of solutions. Among the most notable worldwide are Siemens, Allen-Bradley, Schneider Electric, Mitsubishi, Omron, as well as other brands like Delta and Panasonic. Although all these controllers perform similar functions, they present differences in programming, hardware, and integration capabilities. However, beyond the brand, what really matters is understanding the general operation of the PLC. This knowledge will allow you to easily adapt to any platform and successfully face various automation projects. We have reviewed what a PLC is, its main parts, how it works, and who the most important manufacturers in the industry are. With this foundation, we are ready to move forward and delve into more technical and practical topics related to industrial automation. To keep learning, don't miss the next video in this series. Click on the link that appears here on the screen and let's continue. If you are interested in industrial automation, electrical design, PLC programming, among other topics, I invite you to join the channel by clicking the Join button. By doing so, you will have access to exclusive content, practical resources, downloads, and materials designed especially for channel members.